Good morning, everybody. Hopefully everyone's doing well today. If you can go ahead and give me a green check mark so we know everything's working properly. Today, in School District 23, it's Harmony Day, so I have this wonderful shirt on to remind everyone that it's Harmony Day. I will start with any questions you had from the learning guide from Unit 1. And if there's anything you want to go through there, I'd be happy to talk about it before we move on to the Unit 2 stuff. So our first one is energy flow and ecosystems. That's our first section. We do have some visitors with us this morning. So if we kind of pause everything to allow them to come into the studio, just you guys know why. So they'll be here later. We don't know when, but if you know, I say, hey guys, we're just going to take a few minutes break. It's just to allow them to come in and see the studio sort of thing. So if we do take a break, that's why. Page 32 for sure, Alex, I can jump into that. Is there anything else from the learning guide that anybody wanted to look at? Page 32, I'll jump down there while you guys are thinking about it, maybe looking at it. 31, 32. So, any question in particular there? Alex, I mean, there's 3 questions. So, competition, predation, and biodiversity. I guess these are all kind of like definition type things. Competitions where you have plants or animals competing for a resource. Oh, question 4. Predation. Come on, predation, that's pretty straightforward. Predation is when you have a predator-prey relationship. So I guess the actual definition we include in the course is where an organism eats all or part of another organism. And then an example, we looked at an example of the wolf dealing with the caribou. You could have, coyotes and rabbits. You could have anything, really. Tigers and, I don't know, whatever. Tiger eats antelope or deer or something. Give an example of predation that's likely to occur within the community you live. So you could have a bird hunting a grasshopper, something like that. So it looks like you're all right there. Wondering who's studying for the biome, should we memorize the exact summer and winter temperatures and certain amounts of precipitation each one gets? No, please don't memorize that detailed of information. With the biomes stuff, the main thing is you can differentiate between the biomes. So if I showed you a climatograph, could you say, okay, this area gets, a lot of rain, the temperature's pretty consistent year round, so that's probably a temperate rainforest. Or this area gets a ton of rain and the temperature is really high. It's always about 30 degrees. Well, that's going to be a tropical rainforest. Or an area gets, a little bit of precipitation and the temperature is pretty consistent. It might be a grassland. Depending on how high the temperature is, it might be a desert. So you should be able to kind of, I'm not saying memorize the exact temperature and the exact precipitation values, but you should have a general idea of not what specific areas receive specific amounts of rain and temperature, but why the biomes are where they are. Why is a desert a desert? Desert's easy. Why is a temperate rainforest special? Why is a boreal forest different than a deciduous forest? What makes those things different? So not memorizing specifics, but being able to compare them. Being able to identify what makes each of these things different, that's kind of the key idea between the biomes. And then sometimes you could talk about what plants and animals live in those biomes because of the environment that makes them special and things like that.
What plants and animals live in those biomes.
All right, good stuff. Ava?
Environment.
Anything else? I mean, yeah, the biome section and biology in general is just kind of a lot of stuff, a lot of memorization, a lot of vocab, and I don't love it, but that's kind of a reality of biology. Why do we need to know the difference between a temperate rainforest and a deciduous forest anyway? Taylor, that's a great answer. For the provincial, yeah, I mean, this is the curriculum in BC. I don't decide the curriculum. I mean, generally speaking, we'd like every person who graduates high school in BC to have a general understanding of ecology and the world that they live in. So, I mean, if you can justify it, then fair enough. But I don't have much of an answer beyond that. I'm going to jump right into today's material here. If you come up with anything else in regards to the learning guide, then I can do that. Difference between the rainforests, for sure. I'm just trying to think of how is the easiest for me to come up with that. I think the one difference, without having anything in front of me, Abby, is that when we're looking at a temperate rainforest as compared to a tropical rainforest, temperate means that your temperature doesn't get really high or low. It's just kind of even. So temperate rainforest average temperature, if I recall correctly, is about 12 or so degrees kind of year round. Its temperature is very consistent. The rainfall in a rainforest and a tropical rainforest and a temperate rainforest are about the same. So there isn't a lot of difference. The only thing that's different between them really is the temperature. So if you look at a tropical rainforest climatograph, you're going to see that the temperature is up around the 30-degree mark, whereas a temperate rainforest, it's down around the 15-degree mark. And that's really the only way you can tell the difference. And if you think about it, if you were to go stand in the rainforest, on the coast of, off the coast of Vancouver, maybe Vancouver Island, and then you were to go stand in a rainforest in Costa Rica, what difference would there be? Everything's lush, everything's green. You have, a thick undergrowth on the ground and big trees with canopy at the top. And just the temperature would be the only thing that's really different. They both receive a lot of rainfall. So that's about it. What about the boreal forest? Boreal forest has very big temperature differences. So you're looking at like minus 20, 30 in the winter and then about 20 degrees in the summer. So you have these big temperature fluctuations. And then I don't remember what the rainfall is for the boreal forest off the top of my head. Yeah, I mean, I wouldn't spend a lot of time, memorizing things in regards to the biomes, like I was mentioning before. As long as you can compare them, you'll be okay. That's kind of all we expect. And it's kind of one of these things. You could memorize every temperature and precipitation value for all of them, but I mean, you're going to see a few questions on them, and is it really worth it? Probably not. So if you can compare them, if you know what the differences between them are, that's all we're kind of asking for. So if you can do that, we're okay. And if you guys have more questions about the biomes, I can bring up some stuff at the end. Yeah, Taylor, same deal as before. Once you finish the learning guide and you submit it, I will have a look through it, make sure everything looks good, and then I will send it off. Send off that password to your parents, and then they can supervise your test. Yeah, I'm not a big fan of memorization, so we'll try to avoid that whenever possible. I would love it if you guys just understood why the biomes were where they were, and you could be like, well, that's easy. A grassland is a grassland because, it doesn't receive very much rainfall, but it doesn't necessarily get enough to make it a desert sort of thing. So, all right. Today we're going to talk about energy flow in ecosystems, and the first sort of definition that comes up is biomass. And I love science because we can break down math a lot of times too. We can break down words into their roots to kind of figure out what the definitions are. So biomass. If you were asked on a test, what does biomass mean? Well, you guys know what hopefully bio means, and you know what mass means, or you have a general idea. So if I asked you, what does biomass mean? Could you come up with a definition based on the two sort of root parts of that word? Like biology is bio and ology. And ology means the study of, and then bio is things that are living. So when we start looking at words in science and math, you'll see that their roots often kind of give away a lot of their meaning. So Alex goes with living mass, and Taylor, mass of organisms, both completely correct. So Biomass is the total mass of all living things in a given area. We could talk about the biomass of the planet, or we could talk about the biomass of a pond somewhere near your house. We generally measure it in grams per meter squared. So how many grams of living stuff is there in a meter, area of measure? And then if we're talking a bit bigger in terms of scale, you could talk about kilograms per meter squared, and that would give you an understanding of how much stuff lives there. So places like rainforests have a lot of biomass, whereas places like permanent ice would have very low biomass. So within a biome. Within an organism's niche, so where the organism affects other things around it, it's going to obtain food, it's going to contribute energy to the ecosystem. There's this energy that's constantly flowing. We're going to get into a lot of definitions today, and we are going to, I don't love the definition stuff of this biology section, but there is a lot to take in, so I will warn you. How much biomass does the ocean have? I'm not sure of that number exactly, but you could likely look it up on Google and put it in the chat when you find it. One of the most important processes, if not the most important process that exists in nature that powers every food chain, almost every food chain, is the process of photosynthesis. And you guys will be learning a little bit more about it, a little bit more in depth. So let's take a look at it here. How do living things use what the producers produce? So we have all these living things. We have, a bird, you have me, maybe you have a dog as a pet or a hamster or something. All of the energy starts at the very bottom, and we have all of these producers. And what's going on in photosynthesis that allows all of this energy to be transferred? Anybody think of what's going on? When I eat an apple off a tree, the apple tree has taken energy from the sun, it's taken some nutrients from the ground, it's taken carbon dioxide from the atmosphere, and it's made an apple. And I eat the apple, and I say, this apple is delicious. What is in that apple that's so good that makes it nutritious? Why don't I eat the leaf of an apple tree? That's part of the tree. Why do I eat the fruit instead of the leaf? And some of these ideas coming in are good. So we have the idea of sugar. Everyone's kind of going with sugar. Sugar is good, and that's kind of a part of it. So let's look at the process here. I find this absolutely amazing, and I hope you guys can appreciate it. We talk about the process of photosynthesis. So get my little cursor out here. Don't worry about the numbers out front, the coefficients here, but if you take a molecule of carbon dioxide and you take a molecule of water and you put them together in a plant, and then you end up with C6H12O6. And you guys were exactly right when you said sugar. This C6H12O6, this is glucose. So you've probably heard of glucose before. And Damon, you're right. There's vitamins in plants that we need. The plants need them too. That's how we get vitamins. So photosynthesis takes some carbon dioxide out of the atmosphere, takes some water, puts them together, makes a sugar, and produces some oxygen. Well, what do we need to survive? We need oxygen and we need energy. And that energy is in the form of the sugars that we eat and the food that we choose to eat. So now that sugar is in our body, I eat an apple. That sugar from the apple is now in my body. Pardon me. You end up with this sugar, this oxygen I breathe, and then what happens in my body? Well, I take that sugar and the oxygen, my cells, mitochondria in my cells, they use that, and then they produce some carbon dioxide, they produce some water, and they produce some ATP, which is the energy that your cells use to do. It's called adenosine triphosphate. You don't need to know that, but there you go. So the beauty of this relationship is that plants take in sunlight, carbon dioxide, and water, and they give us sugar. And then we take in sugar, and then we give the plants back carbon dioxide and water. It's just this cycle. It's absolutely amazing. It kind of blows my mind every time I think about it that, this relationship exists between all organisms that are alive. and plants, and we can't have one without the other. So yeah, I guess it comes down to the idea of fresh air. Concentrations of oxygen can be a bit higher in forests, but we'll look at that a little bit later as to why or what's going on with the carbon in the atmosphere. So looking at energy flow, thinking about energy, nutrients, everything that kind of flows through the biomes, the atmosphere, our biosphere. So we talk about consumers. So there's kind of two levels. At the very bottom, you have your producers. That's these leafy green things, plants that we eat. And then you have your consumers. So at the very basic level, you have little things like the bunny and I guess it's like a deer maybe, and a little mouse. So the consumers eat the producers. And then you end up getting bigger things, higher level consumers, and then carnivores. And then once all those things die, you have these detrivores. Or decomposers that break down organic matter. So we're going to look at how this process works. And notice it all starts from the very beginning here. Sun, air, water, soil. All of these abiotic factors, these non-living things, start this whole process. Then we have the plants growing, then the animals eat the plants, and the animals eat the animals, and then everything dies, and then the detrivores eat them. And it's this flow. So we're going to look at in Science 10, 3 different ways to transfer things through the atmosphere, or the biosphere, I should say. So we have energy being transferred in food chains, we have energy being transferred in food webs, and we have energy being transferred in food pyramids. So you can see here behind me, at the top, I have my food chain. Right behind me is the food pyramid. And then over on the far side, there's a food web. So we're going to talk about the differences between all of those things. What would happen if the sun went dark? That's a pretty cool question. Considering that all of the energy that we have on Earth, with the exception of nuclear energy, all came from the sun. All of the energy we use in our everyday lives and the food is all a result of photosynthesis at the most basic level. You would break down almost every food chain on Earth, and there wouldn't be any plants, and then things would just start dying, and it'd be dark too. That'd be sad. All right, let's look at a food chain first, because this is kind of the easiest way to go. The cool thing about a food chain is it just shows energy being transferred in one direction. So you start at the bottom. You start at the bottom with the primary producers, and then you start to go up. Then you have your primary consumers, secondary consumers, tertiary consumers, and then all the way up to the top to the quaternary consumers. This is where the vocab kind of gets a bit tricky, but I think you guys can handle it. So the very bottom of the food chain is your producers. These things take the energy from the sun and they create energy that all animals can use. Where are we on the food chain? It depends what chain you're talking about. If I go out for dinner and I order a salad and there's no meat in it, I'm a primary consumer. I'm in the second tertiary level of the food chain. There's lots of humans that don't eat meat. They're vegetarians. So that puts you in the second trophic level, and you're essentially a herbivore. But there's lots of humans that do eat meat. So, we kind of go higher up the food chain. It depends on the chain. When we say, a food chain, it's not just there's one set level for every living organism. There's lots of different chains that we could be a part of. So we're part of literally millions upon millions of food chains, not just one. We're part of many. All right, so we have the producers at the very bottom, the very basic level. Primary consumers, secondary consumers, third consumers or tertiary consumers, and then all the way up to the top carnivores. So the second set of vocab associated with this is trophic levels. And I will admit that I don't know where the word trophic comes from, but I do know what everything kind of means. So the first trophic level is the bottom. Those are your producers. The second trophic level is the second step, third, fourth, fifth. These are your trophic levels. So each step up a food chain is the next trophic level. Types of consumers. You guys are pretty good at this. I know just about all students have a pretty good grasp of it. What if you're a vegetarian and have animal products like milk? Then where are you? Yeah, you're not eating any meat, technically, I guess. I mean, when we talk about humans, humans are omnivores as a species. Are there exceptions to that? For sure. And if we look at the same thing like bears, bears are omnivores in general as a species. But if you look at polar bears don't have any vegetation to eat. So are they considered carnivores? Well, I guess because there's just no vegetables up there for them. So, there's kind of exceptions to the rule. Just because, a bear eats only meat, does that make it a carnivore? It's kind of up for a bit of discussion and debate. So it's kind of hard for us to kind of place things because there's going to be exceptions to the rules always. Sorry, I'll go back there. All right, so detrivores are the most important part of any food chain because they take all of the waste and they recycle it back into stuff that we can use again as producers and consumers and things like that. So without detrivores, imagine Earth. Think back to like the dinosaurs if you want. So every living thing on Earth that's ever lived, imagine if it was still here, just dead, just lying on the ground. And you're thinking, oh, that would be gross, it'd be stinky and stuff. Well, that stink that you're thinking about, like dead things and rotten things really smell, that's because of bacteria or detrivores breaking it down. Imagine if you had, just like right next to me here, there's just big Tyrannosaurus Rex just hanging out here. It's dead, but nothing's breaking it down. It's just lying there dead. And that's it. And then on top of that, there'd be a bunch of leaves and plants. And you just imagine what the Earth would look like if everything that had ever died on Earth was still there, if it didn't get broken down, turned back into soil, turned back into essentially just dirt. It kind of would be just really weird. So, and Alex, that's a cool question. How do detrivores tell when things are dead? Wouldn't they try to eat everything alive? They do. They do. If you get a cut on your arm and it gets infected, it gets all red, essentially bacteria has infected you. That's bacteria trying to eat you. And, well, what do? Well, you clean it to get rid of the bacteria. You keep it sheltered from bacteria. Your body fights off that bacteria. So we're constantly fighting a battle against detrivores. If I were to just, die and you just left me over behind my building, well, bacteria would start to eat away at my body. My body would lose the fight against these bacteria. But our bodies are constantly fighting off bacteria. And there's some really crazy bacteria, like flesh-eating bacteria. Your body can't fight it off. So what does it do? It starts to eat away and starts to decompose you, essentially. So yeah, right now you have trillions of bacteria all over your body, and they're trying to eat you alive. Pretty crazy. Or not. Yeah, I'm not sure on that one, Ava, exactly. I would assume that it would, your body would start to decompose because of the bacteria inside of you, but there's things going on in our bodies that prevent that from happening. I don't have a good enough understanding of it, unfortunately, to say much more than that. You don't want to be eaten alive? Well, you will be put back into the food chain one way or another, whether you like it or not, unless your body is fired into space. So the important idea here, I'll just jump back, is detrivores, they feed on every level of the food chain. It doesn't matter if you're a top carnivore, if you're a plant at the bottom of the food chain. If you die, you get broken back down. You get turned into soil. The parts that make you what you are, get returned to the ecosystem you're in, and it gets recycled. So detrivores are so important to our ecosystem. We kind of take them for granted, but what are we talking about? Detrivores, bacteria is a big one, fungus. There are things like worms, beetles, a lot of insects are detrivores, and things like that. Detrivores don't try to eat rocks because there's not a lot of nutritional value in rocks, very low. That's why nothing really eats rocks for the sake of eating rocks except for lichens, which we'll talk about later. So the first step in any food chain after producers is going to be your primary consumers, which are considered herbivores. So these are animals that only eat plant matter. And they can get all of their energy needs from just eating plants. And as we talk about these as a species in general, but again, you can think of humans. Well, some humans are vegetarians, and they can survive just off eating plants. So yeah, sure, we can be considered herbivores if you like. So there you go, carnivores. And then when we look at the food chain, there's lots of different levels of carnivores. So as soon as you eat something that's not a plant, you're a carnivore. So we think of a lot of birds. It's kind of weird, but a lot of birds are carnivores because they eat insects. And insects aren't the bottom of the food chain. They're not taking energy from the sun and converting it to sugar through photosynthesis. So birds a lot of times are carnivores, but you don't think like, oh, carnivores. But you guys are talking about vultures in chat, which is an example of a carnivorous bird. Vultures eat dead things usually, right? So they can be considered detrivores for sure. They are carnivores, I guess, because they eat meat, but they like to eat dead meat. So there you go. So those are herbivores. You guys know what those are? I'm just going to pause for a second here. We have some guests coming in, so we'll just be back in a second here. All right, we have two guests here. We have Mr. Kevin Cardall, who is the superintendent of our school district, and we have Dr. Peter Malloy. So I'm going to invite them into our frame here. So this is Mr. Cardall, and behind him, Mr. Malloy, or Dr. Malloy, sorry. And they're both here to see what we do in terms of teaching to you guys this way. So they've probably, well, I know Mr. Malloy's seen this, but Mr. Cardall hasn't. So we have everyone in chat over on the side, and they're all saying hello to you over there.
Hello, everyone.
There you go. I don't know how well they can pick you up my mic here, but there you go. So everyone in chat here.
Just step back and watch it for a bit.
Okay,
Yeah, of course.
We'll step back and
I'll just continue on.
It's a great name, everyone.
There you go. All right, so those are your carnivores. There you go. And then last is omnivores. So we're talking about things that eat both plants and animals. People are example of omnivores: pigs, bears, hens. Like I was saying with bears, you can have some exceptions to rules, right? Polar bears eat only meat because there's just no vegetables there for them to eat. And generally speaking, animals will eat what's available to them, but they do have dietary requirements. So those are our omnivores. Now I have some, I mentioned this before, it's kind of interesting to look back, especially when we talk about like dinosaurs and things. People say, oh, how do you know what dinosaurs ate? And we can look at what their jaw structure looked like, what sort of teeth they had to figure out what their dietary needs were. So what do we think here? What type of consumer is this? Is this going to be a carnivore, an omnivore, or perhaps a herbivore? Or can anyone name the actual animal this came from? I have a bunch. We'll see how good you guys are. This one, I thought we'd start easy. We got omnivore. So we have these big, sharp teeth in the front. And then if you look at the back, these teeth in the back here, these are pretty sharp too. So we got a kind of omnivore, carnivore debate going. If we were to talk about an omnivore, these back teeth would likely be really flat, so they could chew down, break down the leafy greens and things like that. They need to break that down. Saber-toothed tiger. Haley, you actually got it right. This is a tiger. So this is the skull of a tiger. So we're talking about a carnivore here. And I'll show you the difference here. So we have another animal. You can see the teeth here. There's no sharp, pointy teeth at the front. We have no sharp incisors. And the back teeth here, these are all pretty flat. So if I just scroll back here, you can see that a tiger has these really sharp, pointy teeth. And then we go here and we can see that we have these really flat teeth. A giraffe, maybe? I like it. I will tell you, it is a herbivore for sure. Anybody guess what type of herbivore it is? We've got a giraffe. That's the only guess anyone wants to go with? Okay. A horse? Haley, you're really close, actually. This is what a deer skull looks like. So some of you may have even stumbled across these things in the forest. And Yeah, that's what a deer looks like. Let's look at another one. Kind of similar sort of to the previous one. What do we think? First of all, omnivore, herbivore, carnivore. Horse teeth are just like that. We got herbivore. I like it. Shaped like a deer head, yeah. This is for sure herbivore. Those big flat teeth in the back used for breaking down grasses and plants. And a lot of animals like this, one in particular, will regurgitate their food after a while. It's called cud, and then they'll re-chew it to help digest it. So their stomachs aren't good enough to just break it down. Like our stomachs, we eat, food like an apple, and our stomachs are really good at breaking it down. But these need to mechanically break these foods down before they can, digest it properly. I like this. So this is a cow. Yes. So happy. Haley, you're good. And Haley, I like that you said the teeth look like a horse's teeth. So cows, horses, deer, sort of anatomically are all kind of similar. There we go. This is an easy peasy one. Pardon me. You guys can figure out what this is, but notice the teeth. They're really pointy. They're not flat at all. They're made for eating meat, specifically for ripping and tearing meat. And then they can swallow it. This is definitely a carnivore 100%. And this one in particular is an alligator. Alligators have those big wide mouths. So there you go. Got a couple more. What do we think? Herbivore, carnivore? Haley, there's dentists for horses? That's crazy. You learn something every day. And you got to keep the tooth, which I love. I love that. That's cool. This is omnivore, herbivore, carbivore. I think we're getting kind of thrown off by this pointy thing at the front here, this structure. So if I go back to the deer, you notice that the deer has these incisor teeth here at the front. And if you think about how a deer eats, it kind of munches on grass, and it needs those sharp teeth, the flat ones like we have at the front, to pick up that grass. It has to cut the grass somehow. So this animal, that was a cow, alligator is similar. This one has those same front teeth that are used to kind of cut things. So this is a herbivore. And if you look specifically, anyone want to guess the animal? Somebody actually guessed it already for the wrong animal. This was what about those things up on the top of its head? What do you think those are? That's a giraffe. You guys guessed giraffe already. Yeah, Alex, you're good. So giraffes have those kind of like little horn things on the top. Perfect. You're on it. You got it. Okay, I have a couple more, maybe a little bit trickier. This one, again, pay attention to the teeth. You have really sharp ones at the front, and then the back are flat. So this is definitely an omnivore, kind of like our teeth. We have the sharp canines and incisors at the front, and then really flat molars at the back. So even though there's these really sharp, pointy teeth at the front, this is an omnivore because it also has these really flat molars in the back. Haley's guessing a bear. Anybody else want to take a stab at what this might be? Rhino. Rhino would have a big horn on its head. Maybe this one fell off. Lion. Lions are going to be carnivores, so they're only going to have sharp teeth in the back. And Haley's right. Haley, you're good at this game. You know your anatomy fairly well. Okay, so that was bear. As I mentioned before, there can be bears that eat only meat, and sometimes they'll eat only, plants, just kind of opportunistic sort of things. All right, this one's a little bit easier just because of the shape of it, but is it a carnivore, omnivore, herbivore? Yeah, lions definitely are carnivores. They only eat meat. And if you can identify what type it is, we got monkey, omnivore, sorry. It's caveman. I mean, we could argue it's an ape. Just take the generalized thing. A gorilla, this is a chimpanzee. So chimpanzees are omnivores. They have very similar structures to us. They have incisors at the front and these sharp canines and then the flat molars along the back here. So yeah, chimpanzee, gorilla, very similar in terms of anatomy. All right, this one's the trickiest one. I thought I'd throw you guys for a loop with a one at the end. Some of you might recognize what this is. If you've ever seen one, you'll think, oh yeah, that makes sense. This is in fact an animal that lives today on Earth. It looks pretty carnivore-y. I like that. But remember, when your teacher says it's a trick one, then you know he's trying to throw you off. So what is it? Carnivore, omnivore, herbivore? A wild boar. It's pretty similar actually to a wild boar. They have those big tusks at the front. And wild boar, I want to say wild boar are herbivores, but they could be omnivores. We have omnivore, we have herbivore. Any votes for carnivore? What do we think? Those big sharp teeth in the front, what are they going to do with those? Needs braces? I don't know. These ones in the back look pretty straight to me. Just kind of got some interesting things going on in the front here. Maybe a carnivore. I'm glad we had all three. I bet you if I told you the animal type, you could probably guess as to what it ate. And Alex, you're right. Those front teeth, those aren't for eating. They're for defense and other things. Anyone want to take a guess at what type of animal this is? I'll give you a hint. They only live in Africa. It's elephant. It's not an elephant. Alex goes with hippo. That's good. Elephant. So those aren't tusks. Wildebeest, elephant. This is in fact a hippopotamus. So Alex, well done. You get 10 imaginary points for the day. So this is a hippopotamus, and hippos are actually, you won. Good for you. Although Haley, I think, probably guessed the most correctly. I wasn't keeping track though. These things, hippos, are herbivores. So they have these flat teeth in the back where they chew leaves and plants and things like that. Most of the teeth in the front are kind of defense sort of mechanisms, and there you go. So I started to read a little bit about hippos. I'm like, wow, they have these crazy sharp teeth in the front and they're herbivores, like they don't eat any meat at all. And I started to do some reading, and in a few rare cases, hippos have been known to eat their own kind that are dead already, but it's just really rare. There's only been observed a few times. So they are the most deadly animal in Africa. They eat more people or kill more people than tigers, lions, elephants, everything. So extremely deadly, very dangerous animal. We take for granted because they're big. They do eat people a lot. And they're actually closely related to whales. That's their closest kind of ancestors, a whale, which I thought was pretty cool. So there you go. That's the herbivore, carnivore, omnivore game for the day. They do open quite wide. They can munch through a watermelon, no problem. So we need to talk a little bit about food webs and then food pyramids and food chains. I'm doing okay for time here. So most organisms are part of many food chains. That's why a food chain isn't a great way to describe how energy flows through a food or an environment, I should say. So what we do is we like to include food webs, and these food webs show more intricate interactions. So the food web here, you can see all the grasses and plants at the bottom are the producers of all the energy. And then you have consumers. You have different things here eating the grasses. So, the marmot eats the grass, and the grouse eats the grass, and the deer eats the grass. And then, you get up a little bit higher. Well, the grouse also eats a butterfly, which eats the grass. So now a grouse is an omnivore because it's eating an animal, a butterfly, and it's eating a plant. So you have all these really sort of intricate interactions. And the grizzly bear here, he'll eat, just about anything he can get his hands on, including the berries. You have an arrow going from the berries up. And then, you have one going from the deer up. And then there you go. So food web shows many different paths that energy can follow. And the most important thing with food webs and food chains is the arrows show the direction of energy transfer. So even though the bear is eating the berries and the bear is eating the grouse and the bear is eating the deer, the arrow goes from the deer to the bear because that is the energy transfer. The energy gets transferred from the deer to the bear. So the arrow shows the direction of energy transfer. Are frogs carnivores? Yeah, I don't know. I would assume that we kind of think, yeah, frogs eat flies. So maybe frogs eat plants? I'm not sure. I don't know enough about frogs. So there you go. So a keystone species is one that has a greater impact on its community. And if its population gets affected, it has a great effect on other populations. So keystone species are really important in their ecosystems. Are we a keystone species? I think some people would like to think they are. I mean, if humans just disappeared from the ecosystem, would other species really be affected? Some would, some wouldn't. I don't think I'd consider us a keystone. I mean, you could probably argue for it. But while you're thinking about it, British Columbia. What are some keystone species in British Columbia? Things that would have a great impact on their ecosystems. Can anyone think of anything? Take a guess, maybe? I would agree with you, Alex. If humans were to go extinct right now, I would say that probably most species on Earth would be, positively affected, not negatively. So maybe we're not a keystone species. Bees, that's a good example of one. The reason I hesitate to, you could argue for bees for sure. But if, not a lot of things eat bees, so if they were to disappear, would things be really hungry? Well, we have this pollination. Are there other things to pollinate? Yes. So there you go. So deer, I think that deer are kind of plentiful enough that, that we wouldn't really miss them. Things that have a really big impact. And the first one I'm going to show you is probably the best example, but there are, other things. So deer, fish, Haley's guessing fish, grizzly bears, salmon, we're all on the right track here. So I'll give you a couple examples. I'll get out of the way here. So the first one I'm going to talk about is salmon. And salmon are a keystone species in our province for a couple reasons. Salmon live in the water, so they indicate, how clean our waterways are, how unobstructed they are. They indicate the health of waterways. And salmon travel thousands of kilometers from the ocean, up the rivers, to all the way to the interior of BC and all through the interior of British Columbia. And they spawn. Once they spawn, they die. And they become this huge source of food. So salmon would be an excellent example of a keystone species. If the environment as a whole is healthy, there will be plentiful salmon, lots and lots of salmon. Once they die, they feed thousands and thousands and thousands of animals. They feed the bears, they feed the birds. When they break down, their nutrients enter the waterways and they fertilize the land, so plants grow. So salmon are extremely important. If salmon species have a bad year, you can see direct effects on all sorts of animals like bears, and all sorts of other things directly affected within our ecosystems. So that's the first one. The second one might not make as much sense, but beaver is considered a keystone species as well. Can anyone really? My argument with salmon was they lived in the water, and beavers do the same thing. So the beaver is an extremely important indicator of kind of ecosystem health, because it lives in the water. So if our waterways are clean, beavers thrive. If the wetlands are alive, they have lots of food, and they build their own dams and create ecosystems and habitats. And then beavers also live on land, so they become a food source for lots of animals. If there's lots of beavers, then lots of animals eat the beavers. And they're sort of a very important part of our ecosystems because they live on both land and in the water. Now, don't think that a keystone species has to live on land and in the water, but a keystone species has an intricate part in many food chains and food webs. So that is, or those are, I should say, kind of two examples of keystone species within British Columbia. Salmon is a great one. Beaver is also a good one. All right, this might be kind of one of the more interesting, or I don't want to say difficult because it's not difficult, but a topic that we'd like to talk about for sure. It's really important. Food pyramids. So we talked a little bit about food chains, then we've talked about food webs. Now we're going to talk about food pyramids. Now, behind me here, you can see the picture. Now, if I took 1 million joules of energy, it doesn't really need, or you don't necessarily need to know what a joule is, but if you took a million units of energy and you shone those million joules of sunlight onto the earth, the primary producers, so we're talking about plants, grasses, flowers, anything that grows through photosynthesis, they would trap about 10,000 joules of energy. So then you have your primary consumers like grasshoppers and cows and deer, the herbivores. They eat all of that grass and then they end up with about 1,000 joules of energy. So we went from 10,000, now we're going up a step, now we're at 1,000. You take your, so you have your primary producers down at the bottom, your primary consumers. You take your secondary consumers, going up a little higher. These guys eat all of the primary consumers and they're left with about 100 joules of energy. And then you go to the very top of the food chain, top level carnivores, tertiary consumers, they're left with about 10 joules of energy. So the question I've written here is, where is this energy going? We put in 1 million joules. We start at the bottom of our food pyramid with 10,000 joules. By the time we make it to the top, there's 10 left. What happened to it all? Where did it go along the way? Why do we lose 90% of the energy from one level to the next? What's going on there? What processes are happening? Now, it got consumed. Energy gets transferred, it doesn't disappear. Abby, you got a really good point. Help animals grow and live. Think about it this way. If you are a deer, what do you have to do to eat? What sort of process involves a deer obtaining food? Does a deer have to hunt its food, or does it just walk over to a nice lawn somewhere and just start munching? Yeah, hunt, question mark. This is what I'm talking about. They spent the energy. That's right, you guys are all on the right track. So a deer, a primary consumer, we have all of this energy at the bottom, we have this 10,000 joules, we go up to the next level. Well, a deer, it doesn't really have to do much to find food. It just, walks on and finds some grass to eat and eats it, done. What about a bear? What does a bear have to do? Well, a bear is like an omnivore, so it might hunt for some of its food. Maybe it finds a wounded deer, it eats it. That takes energy to, attack an animal. And then you go even higher up the food chain. You're talking about things like our predators. You can have, like the snake is the example here, but you can have birds, like eagles, hawks. What do they have to do? Well, they have to find their prey first, and then they have to wait for the prey to, become available to them. Maybe they have to fly around for a long time. So the higher you get up the food chain, the more energy animals waste on doing things that make them animals. So imagine this for a second, a hypothetical situation. Do we have any vegetarians in our class? If you want to give me a green check, you can. If you're like a closet vegetarian and you don't want to share that with the rest of the class, then you don't have to. So green check any vegetarians or vegans. Everyone kind of eats a little bit of meat. I know we try to do the vegetarian thing at our house, but every once in a while we have some meat. Closet vegetarian. Vegan, awesome. Vegan is hard, man, I tell you. it's difficult to be a vegetarian because you have to have a good understanding of amino acids and are you getting full protein complements and things like that. So it isn't easy. Iron, yeah, that's a big thing. So vegan's even harder. Oh my goodness, I couldn't imagine being vegan. But to get appropriate levels of vitamins, nutrients, your amino acids, your proteins, yeah, I know. I'm with you guys. All right, so now that we got that out of the way, imagine the entire planet, the entire world, all of a sudden today decided, hey, everyone's going to become a vegetarian. Everyone wants to be a vegetarian. So humans, we are enormously destructive in our ecosystems. If you think about farming beef and things like that, that has a tremendous impact on things like the rainforests and forests within our province and things like that. So if we all of a sudden stopped eating meat, we would be able to take this 10,000 joule level here, and we would be obtaining this 1,000 joules of energy. Once we start eating herbivores, we get up to the next level, and you end up losing a lot of energy. So we waste, or carnivores waste tons of energy because the food they eat isn't that high in energy. So if everyone could become a vegetarian, our world's sort of food energy needs would become very low. We could definitely get all the energy the world needed through plants alone. But once you get higher, you start wasting energy. So here we go. You guys were all on this. You did a great job of it. So energy, what happens to it? Pardon me. If you take this mouse, so a mouse would eat things like grains and seeds and things. So let's say it takes in 100 kilojoules. Don't worry about what kilojoules are, but if it takes in 100, you can see here 30 of the 100 just goes into keeping it warm. That is just heat that its body produces. It just gets released back into the environment. So that energy is taken in from the sun, goes into the environment, it's gone forever. About 10 of the 100 use to maintain sort of its body tissue and energy like that. And then about 60 of it is just the food waste that it just poops out along the way. So it's amazing that it can take in this 100 and 30 of it just turns into heat and dissipates, so it's gone. 10 of it is actually being used, and then 60 of it just gets transferred back to the decomposers. So this is what's happening when organisms consume energy. This is why so much is lost. You imagine an eagle, top-level carnivore. So if I'm an eagle, what do I need to do to survive? Well, I'm going to have to find food. So I'm going to have to fly around until I find some food. I'm going to hunt it. Might miss, might get some. You never know. I need to build a nest because I live in a nest. So I'm going to have to go find some sticks, some soft stuff. I'm going to have to find a tree. As a top-level carnivore, I'm wasting a lot of energy. Well, it's not wasted, but I'm using a lot of energy and just living, just surviving. Whereas if I'm a deer, what am I doing? Well, I just walk over to a patch of grass, I eat some, and there you go. Same with cows. Cows don't expend a lot of energy on, evading prey and things like that. So this is where the energy goes, into keeping the organism alive. So food pyramids are really important because they show how much energy is lost in each level of the, as you go up the food chain. So the important thing for you to remember is that each level going up the food chain loses 90% of the energy. So if you start with 100 at the bottom here, the producers start with 100, you go up to herbivores, you've lost 90, so you're left with 10. This is 10. And you go up again, you've lost 90, so you're left with 1. And you go up again, you've lost 10, so you're down to 0.1. So you started with 100 down at the producers, you're left with 0.1 energies once you make it to the top carnivore. All right, so I'm a little confused though because modern day life humans don't usually go and hunt their own food. You're right, we don't. But what do we do to get food? Well, you have to drive to the store. How did you do that? Well, you jumped in your car. Well, how did your car get the energy to move? Well, it used gasoline. So you break down the bonds in the gasoline, there's energy there. That's how you got to the store. If you didn't have a car, you'd walk. So the energy expelled moving from your house to the store to get food, or from your house to the orchard to get food, or from your house to the forest to get food, we take for granted because we use stored energy in gasoline. But assuming you did it on your own, you'd have to consume that energy to get there. So we've supplemented our energy needs with hydrocarbons, propane. Imagine living without a heater in your house. Well, how does your house get heat? You either have an electric furnace or you have a gas furnace. What is that doing? It's taking electricity, converting it to heat to keep you warm so you don't have to stay as warm. You don't have to wear a bunch of jackets. You don't have to eat a bunch of calories to stay warm. We have supplemented our lifestyles with energy, with condensed forms of energy. So there you go. Don't deer use a lot of energy running away from predators? Yeah, they do, for sure. That's part of their lives. That is energy that they need to use to survive. So if you're, starving, if you're a deer, you're starving, you try to run away, maybe you don't get away because you couldn't evade that predator. Then you die. Now you're food for someone else. So this happens all the time. If a food source disappears, then you end up with, things that need to happen. Either the animal dies or it finds another food source. But there's energy being expended, getting away. All right, food pyramids. The important thing here, 90% of energy is lost. We'll see you later, Savannah, thanks. 90% of energy is lost going from one step to the next. That's what's important. We can call it the rule of 10. You can call it whatever you want, as long as you remember that 90% disappears along the way. How does it disappear? It turns into body heat, which evaporates into the environment. But basically, the tissues, the cells of the organism only save about 10% along the way. 90% of it disappears. So there you go. There's 3 different types of pyramids we could talk about. We've looked at the pyramids of energy, so that's the far one here. Pyramids of biomass shows how the mass of organisms along the way. So generally speaking, the bottom of your pyramid will have a ton of mass, and then as you go up the pyramid, the mass will get smaller and smaller. If you think about it, if you weighed all of the grass in the Okanagan, it would be literally tons and tons of grass. And then you take a top-level carnivore like a bald eagle, it would be the mass of all of the bald eagles in the Okanagan Valley. Well, maybe it'd be a couple hundred kilograms. So you're going from thousands of kilograms. When you get to the top, there's only maybe a couple hundred or less than 100 left. And then the pyramid of numbers behind me here is the same idea. As you go up a food chain, if you counted the amount of grass at the bottom, there'd be millions and millions of grass. And then you get to the top to your top carnivores like a cougar. Well, now there's only maybe, 100 cougars in the Okanagan Valley or whatever the case is. So those are the 3 you can come up with. That is ecosystem energy transfer in a nutshell. So that's section 2.1 in the course. So we've just started it in the course. Maybe I'll jump over there. There is an example, a few examples in the energy flow and ecosystem section here. So there's a couple things for you to practice. There's a quiz and a crossword puzzle right in there at the end. And then a check your understanding. So it's kind of like a quiz that's just built in to the course. So this is where we're at. We'll have the video up later today, maybe tomorrow morning. And that's kind of where we're at right now. So we're going to do nutrient cycles, bioaccumulation. So 2 more days and we'll be done. I shouldn't say that. Nutrient cycles might take a little bit because it's a bit of a long one. But bioaccumulation is a really quick one. So probably 2 more days and we'll be done unit 2. It's not terribly long. When would you like the unit 1 test done? I would love it if it was done sooner rather than later, but I think I put in some dates here. I would love it if you submitted Unit 1 Learning Guide today. You should be done it. We've moved on, so we're on Unit 2 already. So if you had any questions, you've asked them. Submit the Learning Guide for Unit 1 today, and I'll give you guys a couple days to get the test done. So assuming you get the Learning Guide for Unit 1 in today, you have, I think I put Friday, yes, February 19th. So you have a couple days to get that test done. If you wanted to do it today, awesome. I'll have that password sent out to you. If you want to wait, maybe study for a day tomorrow, get the test done on Friday, that would be great too. So that's kind of where we're at in terms of that. I would love it if that was done for Friday. How many questions on the test? I'm pretty sure there's 20, like all of the tests. There might be a few less, might be like 18. But I think generally speaking, they're all around 20 questions. So kind of everything broken down, everything's kind of equally represented. Nothing's more important. Realistically speaking, there's only really 2 sections, biomes, ecosystems. There's a lot of vocab in there though. Yeah, if you submitted the learning guide, I think you did that yesterday, Ava. I think I checked and I saw that. Yeah, if you submitted it, then I'll get the password out to you today for sure. And you can do whenever you want. I know Abby wanted me to print off the Unit 2 learning guide for the art gallery today. So if anybody else wants that, you could just message me in chat right now or send a message through Moodle and I'll have that printed off for you. And if you want to bring in your learning guide at the art gallery today, I'm not going to be there. Mrs. Wood will be. And you can give it to her and she'll make sure I receive it. So there you go. That's where we're at. That's where we're going. We're going to just keep rolling. We don't have time to stop. I won't see you guys again until next week on, I think, Tuesday. We have a double block, so we're going to spend a little bit more time, which is good because the nutrient cycles is a long section. I want to, but I'm not coming to the art gallery. Okay, Haley, I'll print one off for you. I'll leave it here. And if somebody is around, they can just swing by and I'll have it waiting for you. So there we go. Does anyone have any further questions before we get out of here for the day? Doing okay? I'm not sure. I think Mrs. Wood's gonna do some electives with you guys again today or talk to you for a bit. So at 10:30 you can sign in with Mrs. Wood. I know I was supposed to take the whole block, but I have to teach at KSS at 10:30. So we kind of booked the whole morning for you guys, and I talked to Mrs. Wood, and she said she was going to do some stuff with you. So if you can sign into Mrs. Wood's Blackboard at 10:30, that would be great. Instead of it being more science, it'll be some elective stuff. So there you go. And yeah, hopefully you guys can get that learning guide for Unit 1 in today, have that test written by Friday, and then we'll just keep plugging away. So everyone have a great afternoon. Hopefully you have fun at the art gallery, and enjoy your weekend. We'll see you guys next week. Thanks.